Okay, good morning everyone. Today we are continuing with our chapter number second. We are going to revise this chapter, okay, for UML diagrams. In last two sessions, we have seen about UML diagrams, types of UML diagrams, some examples, history about UML diagrams. Today we are going to see some examples about the remaining one, okay. In yesterday's session, we have seen about UML diagram basics, history, contribution to UML diagrams, some models, then contribution, systems, models and views. Okay, use case view, that is logical view, implementation view, process view and deployment view. In your all chapters are independent. Oh, sorry, your all chapters are dependent on each other. Okay, your second chapter is dependent on first, third is dependent on second. Okay, all concepts are interrelated to each other. We have seen some basic modeling steps, use cases, domain model, design model. Okay, we have seen the what is actor, what is use case. Okay, we have seen the example, then relationship between the relationship in use cases, what is extends relationship, what is includes relationship. Okay, we have seen the uses of use cases like determining the requirements, communicating with clients, generating some test cases. We have seen the class diagrams. Class diagram, that is what is class diagram, what it includes, what are the relationship between classes, okay, what are the attributes, how to declare, what are the types of attributes, what are the operations. We have seen the instances, we have seen the object diagrams, okay, how to represent the instances. We have seen some notations for class diagram, some modifiers like public, private and protected. Then we have seen some notations or some associations or some relationship in classes, that is association, aggregation, composition, inheritance. Okay, so we have seen the binary association. All these parts are included in your third chapter also. Okay, so your third chapter also contains the relationship between the structural diagrams. Okay, mute yourself. Binary association, we have seen the binary association. That means you consider the class A and class B, both class knows about each other. Okay, both class knows each other. Here you can see the A can see the contents of B, B can see the contents of A. Okay, here you can see the my B dot service. Okay, my A dot do something, this is the function, this function is for class A and this is for class B. Okay, so both classes knows about each other, this is binary association. Then we have seen another association. That means A knows about B, but B don't know about A. Okay, here you can see my B dot service, that is included in class B. This function or this operation is in class B. That means A knows about B, but B don't know about anything about class A. This is another operation, one way. Then aggregation. We have seen the aggregation. It is an association with a collection member. Okay, collection member relationship. How to note that? This is the notation for aggregation. Here you can see hollow diamond on the collection side. Okay, here you can see the create what to create module. Avtade Rutuja, don't do anything on slides. Here you can see the class create and class module. This is the collection class. Okay, here you can see the hollow diamond is on the collection side. This is the aggregation relationship. Then we have seen the composition. Here the fill diamond at the collection side. Here you can see the class team. Team includes the number of employees. Here you can see the relationship multiplicities, one to many. One team having multiple employees. Okay. Here you can see the one team having multiple employees. This is the one to many relationship with composition relationship. Okay. Here the team class includes the object members and the class employee. Here you can see the class employee having several attributes and several functions. This is the composition relationship. Then we have seen the inheritance. This is the Here you can see the base class is A and derived class is B. Here how to give the relationship between both classes, that is inheritance. Okay. Here you can see the inheritance relationship. Class B extends from class A. Okay. Then we have seen the multiplicities 0 to 1, 0 to many, exactly 1, and 1 to many. Okay. Then we have also seen the example of class diagram and association between the classes. Okay. Then we have seen the relationship between the classes. Here association details. Here you can see the hollow diamond, field hollow diamond. Okay. Here you can assign names to the end of the association. Okay. This is the group or this is the individual. Here you can see the team. Team is the collection of employees. Here you can see the class name employee. Here you can see the object of that class. Okay. Members. This is the single class. Okay. Here you can see the relationship between classes. Here one to many, one team having many employees. Okay. Then we have seen the object diagrams. Okay, how to declare that object diagram. Here you can see the format. Here this is the instance name, this is the class name. Always remember that whenever we are going to declare the object diagram, whenever we are going to draw the object diagram, we have to underline the instance name and class name. Okay, this is the format. Here you can see object name colon class name, this is underline. Okay, this is the object diagram name, this is the id label and class name, and these are the attributes with their values. This is how we can declare object diagram. Here you can see the objects and links between that object diagram. Here you can see the several classes with their objects, and where we have linked that objects to one another. Okay. Then we have seen the package diagrams. To organize the complex class diagrams, we can group that classes into package. We can create a package which includes multiple classes. Okay, whenever system is complex, so we can group that complex classes into one package. Okay, one package contains the several classes. How to note that? What is the notation for package is? It is appear as a rectangle with small tabs at the top. Here you can see, yeah, small rectangle at the top. Okay, this is how we can declare the package diagram. Here dispatcher interface is one package which includes several classes in there. Okay, these are the three packages. Okay, these packages are dependent on this package. Okay, this is the example of package diagram. How to draw this package diagram? See this. Then we have seen the interaction diagrams. Interaction diagrams are dynamic. They describe how objects are collaborate with each other. Here we can see the in interaction diagram, we can see the sequence diagram. Okay, interaction diagrams include sequence diagram and timing diagram. Okay, here interaction diagrams include sequence diagram. It indicates what messages are sent and when. Okay, time progress bar, objects. Okay, here you can see the example of sequence diagram. Here this is the actor from the use case. These are the objects. Okay, objects of the classes. Okay, so these are the activation bar. Here this is the activation bar. This you can call this as the lifeline. Okay, here this is the calls to the objects, and this is the dash line indicates the reply from that object. Okay, here you can see the example, enter item number. This is the call to the this object process order screen. Then next call is to item class. Okay, this is find the item. Okay, then next call is to stock item, that get the quantity. Okay, then this process order screen returns the message to actor, that is it displays the details of that item. Okay, this is the sequence diagram. Then this is the sequence diagram with timing. Okay, you can give the time slot. Okay, within that time that reply has to be come. Then we have seen the collaboration diagram. Okay, it shows the similar information to sequence diagram. That interaction diagrams includes sequence diagram and collaboration diagram. Okay, it is similar to sequence diagram, but only difference is that there is a vertical sequence is there in collaboration diagram. Here you can see Okay, here this is the object of this class. These are the object of this class. Okay, here you can see the messages are passes to objects here of here you can see the messages are passes between the objects. Okay, there is the similarity between sequence diagram and collaboration diagram. This sequence diagram and collaboration diagram are included in interaction diagram. Then we have seen the activity diagrams. Okay, here we have seen the examples of activity diagram. This is like flow charts. Flow charts. Okay, here we have seen the example. This is the symbol for start. Okay, then this rounded rectangle indicates the activity. Okay, here this bar indicates the fork. Fork means whenever we are going to include that fork, it will create two sub processes. Okay, and join is for to combine that two processes. Okay, here you can see the example for ATM machine. Whenever customer, okay, here you can see the customer, ATM machine and bank, three systems are there for validation of ATM pin. Okay, here we have started the process, we have inserted the card at the customer side. This is the activity, we have entered the pin. Then next we are going to authorize that pin. Okay, this is the conditional box. Okay, we are going to validate that pin. If it is invalid, then here you can see the bar, arrow indicates that eject the card, take the card, and this is the symbol for end that activity. Okay, if this pin is valid, then process further. Then we are going to enter the amount. Then we are going to, then bank will check the account balance. If balance is greater than the amount, then we are going to withdraw or debit that amount from that account. Okay, if it is less than, then we are going to execute. Okay, we are going to show the balance and exit the system. Okay, here you can see the fork and join. This is the activity diagram. Okay, how to draw this? See this. This is the start the activity. This indicate rounded rectangle indicates the activity. This is the conditional box, or you can see the branch. Okay, this is the fork, this is the join, and this is the symbol for end. Then we have seen the state transition diagrams. Okay, it shows the possible state of the objects. Okay, states are rounded rectangles, transitions are arrows. Okay, from one state to another. Here you can see the example. Here you can see the rounded rectangles. Okay, these are the states of the system. Okay, this arrow indicates the messages. Okay, these are the states of the system, and these are the, this arrow indicates the messages to that objects. Okay, then we have seen the component diagrams. It shows the various components in the system and their dependencies, interfaces. Okay, usually it is a physical collection of classes similar to a package diagram. Okay, here you can see the components are shown as a rectangles with two tabs at the upper left. Okay, at the upper left side. Here you can see the declaration of component, how to draw the component. Okay, these are the two tabs at the left side. Okay, this is the component. Here you can see the components are communicating with each other through the interfaces. Here you can see the rectangle with the solid line. Okay, here you can see the component name is body, and this is the way there are components are interacting with each other through this circle, that is interface. Then we have seen the deployment diagrams. Okay, the deployment diagram shows that the physical architecture of hardware and software of the deployed system. Whenever we are going to deploy any system, we are going to provide some hardware parts or some software, okay, to the end user. We are going to show some physical relationship among software and hardware in delivery system. Okay, here you can see the example. See that the deployment component includes some components. Okay, then we are going to deploy the system, that it includes some software, some hardware components. Okay, this is the example for deployment diagram. This is the deployment diagram for a system. Here you can see the deployment diagram for bank system. Here you can see the bank server, we are going to provide bank system. This is the, you can see how we can draw the deployment diagram. Okay, we can provide the database, customer database, and have some applications for banking system. Okay, here you can say the relationship. This is the dependency. This arrow indicates the dependency between that interfaces. Okay, this is the node, how we can draw the deployment diagram. This is called as a node. Okay, this is The solid line with circle indicates the interface. Okay, this is the connection, how we can connect two nodes. Okay, this is the all about deployment diagram. Okay,